Hello everyone. Today we are here to discuss about Salesforce Apex Enterprise Patterns. Talking about me, my name is Aman Sharma and I'm a Salesforce developer at Eternal Solutions Private Limited. I'm 3x Salesforce certified and below are my LinkedIn and Twitter handles where you can connect with me if you have any queries. So what is the agenda of today's topic? So the agenda of today's topic is how can we implement the classes using Apex Enterprise Pattern and how can we write efficient and meaningful unit tests. And when should we actually go for Apex Enterprise Pattern framework, or we can just write the classes in our traditional way? Okay. So coming to that, what is Apex Enterprise Pattern? Apex Enterprise Pattern is an open source framework originally which was created by Financial Force and based on Java's Mockito framework. It follows the principle of SOC, separation of concern, which comprises of presentation, in which mostly the parts where we see like the layouts, the formulas, dashboards, they are included. And in terms of coding, we can say the Apex controller, visual force, or lightning components, they all comprise of presentation. Business logic layer is nothing but the business logic happening in the backend of the UI. So it can be a formula, it can be a validation, it can be a workflow process builder or sharing rules. And in terms of coding, it can be Apex services or Apex custom actions. Data access layer. So what is data access layer? Data access layer is that layer which can directly communicate with the database to get the data or to post the data. So in terms of declarative, we can say data loaders from which we can do a insert or maybe a update or maybe a delete or upset as well. And in terms of coding, we can use Sockle and then we can use Saucer and we can use Salesforce APIs as well. And then comes the database layer. So database layer is nothing but the connection between the UI and the data layer and the database. So whenever we do a operation in the UI, a operation is performed in the backend at the database as well. So in terms of declarative, it can be custom objects. So when we create a custom object, backend the process is fired. When we create a field, when we create a relationships or rollups. And in terms of coding, it can be Apex triggers, which we can use to manipulate the data which is being passed. So considerations for like when we should go for implementing SOC or when we shouldn't. So depending on the base size of solution or code and the number of developers, let's say if the base size is code, the code base is really small and the number of developers is around 1 to 2. So in that case, it is preferable that we don't use the Apex Enterprise pattern or the SOC to implement that. But whereas the base code base is small to medium and the number of developers is around 1 to 6, then in that case it is worth considering that we may use separation of concern in that code base. And when the code base is large and greater than 6, then using SOC or Apex Enterprise Pattern Framework has its own benefits. So let's consider a real-time scenario where the code base is large, and let's say we have around 200 classes in our org. 200 just classes, not test classes. And so for the 200 classes, we'll have another 200 test classes. So let's say we already have built some automations in account and then maybe contact and then maybe in leads. So there might be some operations where these things might be happening, and in the test class, we might be inserting the data to test that. So in that case, whenever account is being created in the test class, what happens is the account is being created, but it is going through the phase of the validation as well, phase of the process builder as well, and workflow. All those it goes through, and then the data is committed. So the time is taken there. We just want to test the class and not the process builders and the automation if they are working fine or not. But we just want to test the class, but then the number of automations have increased. So in that case, what happens is the time taken by the DML also increases. So it may take more time to commit the DML because a lot of operation may be happening in the background. So when we write so many test classes, so it is eventually that all the test classes will take a lot of time or most of the, not all, most of the test classes will take a lot of time, end up taking a lot of time on the test class running only. Whereas if we implement Apex Enterprise pattern in this, then we won't actually need to do a DML to perform the we won't actually need to do a DML to perform the unit tests for the service class or a simple class, whatever we are writing or the unit test for. So the layers which are involved in this are the domain layer, the service layer, the selectors, and the unit of work. So in domain layer, what we have is, it's just like we can say the point of entry for the code. So the domain layer will be the point of entry from maybe a trigger. It can be, so it can be a trigger where the point of entry of code will be there, and it will call the service class where all the logic will be written, where all the business logic will be written in the business layer. And all the business logic will be written in the business layer. It is also called a service layer. So in domain layer, it is uh, recommended that for each S object, we have one class associated with that S object. And the domain class are mostly passed through to service method. That means whatever is there in service method, we generally call those methods, and we don't actually write on implementing the functionality there. We just try to transfer the call from domain layer to the business layer or the service layer. For this, we write unit test to pass if the to test if the conditions satisfy or not. Business layer, it is encapsulated in the service class. So basically, in the business layer, everything, all the business logic, whatever is there, it can be a validation we have written in Apex or anything. It will all be there, or maybe a addition of two fields, or maybe roll up kind of a thing. It can all be in the business layer. And generally, it is preferred that business layers methods are always non-static and not static. So why non-static? We will come discuss about it more once we reach the demo. And yes, the unit test for this service layer will be totally done without actually doing a DML or a socle. Selector layer. Selector layer contains query, and it is preferred that we have one class per S object. So if we have query on account, then we can have account selector. Suppose if we have a query on opportunity, then can have opportunity selector. And suppose if we have contact selector, then we can have contact selector. So that is how a selector class is created. But if we see the base way, the one which they have given, that there we can see that in that we have to create an interface and create its entry in application class as well, and then we create a selector class. So first the interface is created, then selector class is created, and then we need to create its entry in the application class as well. So in this way, what happens is we need to manage a lot of things, like we need to handle a lot of things like updating the application class, like whenever we create a selector, and so we are going to discuss about an approach in this demo where we can leverage the functionality without using the application class. Unit of work. So unit of work is used for optimizing the DML transactions. So let's say in a transaction we have three inserts happening: one insert of account, one insert of contact, one insert of opportunity. So if we go by the traditional way, then the number of DMLs happening in that transaction is 3. But if we introduce unit of work there, then the number of DMLs happening will be 1, because unit of work combines all the inserts into one and then puts it to the database. So the commonly used methods are register dirty, register new, register deleted, and commit work. So register dirty is more like a update, you can say. Register new is like insert, register deleted is for delete, commit work is for commit, like committing to the database. So here in the four methods, only register dirty, register new, and register deleted, they accept parameters which can either be a S object or a list of S objects. But whereas commit work never accepts a parameter. And whenever we say register dirty, that doesn't mean a data is created in and the record is created in the database. It just means that it is stored in a list, and whenever we register dirty or register new or register deleted, it is just stored in a list and not actually committed to the database. When we say commit work, that time the data which is stored there in the list will be committed to the database. Apex mocks. So mocking in unit tests. How can we mock the classes, like when we have a call, when in a class we have a call from one class to another class, and if in a standard way, if we write the test class, then it will end up going to the other class as well. So how can we actually just test that class and not the other class which it is going to? So we can do this by using apex mocks again. And how can we how can we do a unit test without performing a TML? So that is also again using ApexMocks. And suppose if we are updating a record, then how do we verify that if the record was updated as it was supposed to be? Then again we have a standard functionality given to us by ApexMocks, which we can leverage and use to verify the data. Now let's move to the demo. Okay. Let's say this is a contact trigger where I have a scenario that I have created a custom field in account named as count of contacts, which updates the count whenever whenever a contact is inserted or updated. Updated as in previously it may be associated with account one, but now it is associated with account two. So in that case, it should update the logic that whenever the account is updated, it should update the count of contacts for that account. So in the traditional way, how we will write is we'll write the trigger, and then we'll call a handler class, from where we will call the helper class where the business logic will be written. So contact trigger helper. So from here we just directly call the contact trigger handler and after insert. So contact trigger handler dot after insert, and it got list of contacts and it passed list of contacts. So contact trigger helper again calls update count of contacts and insert. This is the method which is calling. So whenever the contact is inserted, whenever if the list is empty, it returns, else it creates a set and then adds all the account IDs into that set and pass the set of account IDs to a different method. So here is the different method. Here it is accepting a set of account IDs and it's creating a list, and then it's iterating over the list of accounts by querying. So the query is parent to child. Here the query is on the parent account and the child records are being queried. So here the field is being updated. Count of contacts is equal to account.contacts.size, and list of account to update dot add each account. So that object is being added to a list, and then we are checking if it is empty, then update, else not. Again, if we see the update of this, then we can see there is a check. If list of contacts is empty, then return, else it will continue where the set of account IDs will be stored if the both the account IDs are different. That means old account ID is different and the new account ID is different. So both are added into the set and then it is passed. So in the set of account IDs, again it will come here to this method where the set of account IDs is captured, and again that query is executed, and then the count of contact is updated on the account, and again the list is checked if it is empty or not, and then it is updated. So if we see the okay if we see the test class for this, If we see the test class for this, then we can see here list. I have created list of contact account, and sorry, I have created two accounts, and then I've created accounts, and then I have created contacts and update added those into the added those contacts into the list and inserted the list, and then I updated one of the accounts and I did update. So to do a assert, I need to query the data from the account, the data from the database again, and then assert if the data was set correctly or not. So that means again another SQL query is introduced, and and you can see how many DMLs are happening: one, two, and three. So number of DMLs are three, and SQL queries are also happening. And same for the other method for insert. I created two accounts and then two contacts, and then I inserted this contact. And then again, for asserting this, I need to query on these two accounts and check the value of count of contact and verify if they were set correctly or not. So that means again another query is increased, and again the number of DMLs are two. So here, as the business logic keeps on increasing, as the business logic gets increasing, or maybe a bit different, so the number of data can keep on increasing. So this is the traditional way. Now, if we go and see the how we can implement using Apex Enterprise pattern. So as you can see here, contact trigger is calling contact trigger handler new dot get instance dot after insert. So here, so these are the two basic pillars which will always be needed when you want to mock a class. So what is this? This is a class level variable which stores the instance of that class, and this checks if this has an instance, then return it, else assign a new instance to this. So this is the functionality of this method. So since this is a static method, we can directly call. So if we just call this method, that means we are getting an instance. That means we are getting an instance of this class. So if we have an instance, then we can directly say dot after instance, dot after insert. So same way what we have done here is contact trigger handler new dot get instance dot after insert, because till this part it's just the instance. This part returns the instance of that class. So here we call it like this. And again, if you see the other one, after update, it's like that. So the reason why is I said the method should be non-static, because if we are accessing it through a object, then it should be non-static. Otherwise, we won't be able to access it through here. So since we will be able to access it through here, that's why we make the method just non-static. Now coming to this test class, I'll show you. Like as I said, the test class will test only this that class functionality and not others. So if we see the after insert test, so this is the line which is like mandatory when we want to do a mocking in the test class. So this is the line which will always be mandatory, which will always be there. So you can say this is the class which I want to mock, contact service. Contacts, I created an object of that class by using this mocks. It has a method mock and passing the class name to it, and then typecasting it to contact service. So this stores the instance of that class, and then contact service. So this is a class which is going to come in picture. Okay, here. So contact service is getting called from here, and it also has dot get instance. So what I want is that call should not go till that class. The call should stay till here. That means I don't want the execution to reach till this side of the code. So that's why I have written a line and assigned the mock value to it. That means until and unless I specify values, it won't return anything, or nor it will go there. So here I created contact objects, and then I put them in a list, and then I passed. And then I checked if contact service, this method was called. How many times? One time. And what was the parameter passed? List of contact. So this is just like other system.assert we put. And same I've done in after update test as well, that I'm again creating the data here, and again I'm saying contact service dot equal to mock contact service, and again I assign the mock created here to the instance, the one which is created here, it is assigned to the instance of that class. And then again we verify here that this method was called just once and not twice. and these parameters were passed. So in this scenario, when you put a debug here, let's say this class this method is getting called. So let's say you put a debug inside this class, and when this test class is executing, you won't be able to see the debug what is being put here because we have mocked that class. That means the execution will never reach here. Okay. Now coming to the service class. So service class is called from here. Contact service is it is called from here, from the trigger handler. It is called, and contact service the data is passed. Here I'll write all my logic. So same thing I've written here as well. I have created a class level variable which stores the instance of that class, and I have a method which checks if that instance has a value, then it returns a value, or else it assigns a new value to this. Again, this is the unit of work. The unit of work is even here we have used the same concept. If unit of work is null, then assign a new unit of work, else just return what it has. If it is not null, then no need to create do an do a initialization again. And we have a setter as well here where we can set the value of unit of work. And here this is a list, it accepts the list. So here we can say account.subjective and contact. That means we are going to update two types of record in this unit of work, account and contact. But suppose if we do a lead and if you don't specify here, then the error will be thrown that it would the unit of work will not understand that it has to perform a DML for that object as well. So whatever object we need to perform DML for, we need to specify here. Okay. So this method is same as of there. This method is also the only difference here is in this method. Update account based on contact. Here there was a query before, and here I had used a list, and then I was checking here if it is empty. If it is not empty, then update. So what I have created here is I have created a new selector. Okay. Okay. So before we look at a new selector, let's see a old selector, like how it is actually written. So if we see this opportunity selector extends FFlip as object selector and implements I opportunity selector. So first we need to create this class. Then after that we need to create this class which will extend this class and then implements this class. So whenever we want to create a selector, we need to extend this and we need to implement a interface class. So suppose if I'm creating for contact, then here I contact selector will come and this will be contact selector and this will remain same. So before I can create a contact selector, I will need to create an interface for that. And I was talking about the application class as well. So in the application class, as you can see, there is an entry for selector. So here we need to specify that if opportunity is the subject type, then its selector is opportunity selector. So every time you create a new selector for the subject, you will need to come and specify here every time by the traditional way. But let's go and see like how I've implemented it. The way I've implemented is I have not extended a subject selector, neither I have implemented a interface. I have just created these two methods. One is the class level instantiated variable, and the another one is which checks the instantiated variable and returns value if it is not null. So again, it is same like that. All the other methods will be non-static, and the methods inside this will be accessed using this get instance. So here I created a method where the query is actually happening. Select ID, comma select ID from contact where ID in set of account IDs. So the query which was actually where is it? So the query which was here, select ID from this. I have moved this query into account selector, and the query will happen here, and it will just return list of accounts, and it will iterate over each account passed. One more thing in the selector is we can have these kind of generic methods which accepts set of account IDs and field names. So the user can pass whatever fields he require for that account and he can get those fields. Suppose I just want ID and name. So I'll just pass ID and name in the field names, the two. the two strings. And suppose if someone wants ID, name, and then the company, so that user will pass ID, name, and company. So instead of hard coding the values, we are like avoiding to hard code the values here as well. Then here again, as usual, I have written account selector new dot get instance dot get account along with related contacts. And here I'm passing set of account IDs, which will be captured here. Then I'm iterating over those and I'm updating the count of contacts as the same way what we were doing there. Now, instead of putting it into a list, I have put it inside the unit of work and said register dirty. So when I say register dirty, that means update. So that means the record is being pushed into that list where it is supposed to be updated. So once this for loop is completed, once this line executes, only after that the data gets committed into the database. Before that, the data is not committed. Okay, let's see the test class for this. Okay, as I had said, this is the important line which will always come into the picture when we want to mock. So here is the account selector and here is the subject unit of work. So what I've done here is I want to mock this account selector because I don't want the actual query happening when it goes here. So I don't want the query to run. So that's why I have mocked that class as well. And then I have mocked the unit of work as well so that when this commit work happens, it doesn't actually commit to the database. So this is like mocking. So you can consider this more like that. Like while writing the REST API test class, when we write its test class, we actually implement a HTTP mock callout, and there we say, like, if the get is hit, if the get method is hit with this, then return this. If post is hit with this, then return this. Like how we make the service API and APIs understand that it is actually hitting the service, but then backend we had configured it such a way that it was actually hitting the mock callout class that we had implemented. So same way we are doing here. Like when the execution goes here, it will think it is going to the database, but actually we have set the data in the test class itself, and then it won't go to the database. And how we set the data, we'll see that soon. So for account selector new, since it's returning a data, so we need to give something back to it. Whereas in terms of unit of work, it's not returning any data. We just need to assign that mock so that the actual DML doesn't happen. So here I created the data and then, okay, this is the part where I am creating a record of account so that I can return, because in the query, if you must have noticed, it is a parent to child query. So forming a data for account like this is impossible. It's not possible by the standard way. So this this S object fabricator is there, which we can use, and it is not a part of this package though. We can install it. There is a separate link for that. If needed, I can get that for you. But we can install that and leverage that to create records of S objects. So two methods I'm aware of. One is set children, means when a parent to child query is there, so I can set multiple childs, and the other is set parent. So let's say I was forming the data of contact and I want some data of account to be populated as well in that contact. So I'll use set parent in that case and set the data. The one interesting thing about this is, as we'll not be able to set a formula field through here ever, because for formula field we need to make a query happen, then only the formula field will get the value. But using this, we can give the values to formula field as well. Let's say the formula field name is formula field underscore c. Then let's say its value is value. So we can give value to the formula field as we want. So that's not a problem. And suppose again, if here also I want to give the value to a formula field, then it would be value and then formula field underscore c. So the formula field name and then the value. We can assign the values to a formula field as well in this way. And then this is the main part where we say start stubbing and stop stubbing. It is like start test and stop test. like where we will define whenever this method is called with this thing, give this. Whenever this method is called with this parameters, give this. So let's say instead of having it once, we had it twice here. So whenever accounts selector, this method is called with obj account one.id, it will return account record. And whenever it gets the id as obj account 2.id, then it should return account record 1. So we can have multiple mocking for the same method as well. So after the all the mocks are done, we will say mock.stop subbing after we define everything. Then we say test.startTest and test.stopTest. And then we call the methods of the class by passing the data. After this is more of a system.assert, like how we put, because this will fail even if the slightest of the data is missing. So this is nothing but the unit of work verifying that register dirty was called how many times? One time. With what record? Account whose ID was this, an account whose count of contact was equal to this. So this is how we verify the values of each field as well when we create a record using the unit of work. And then we verify here that unit of work was called just one. Unit of work commit work just was called just once, not more than once. And then we check this method was called once. Like I said that time, suppose if we had a method here, obj account 1 2, and this is 1, and suppose if I had written here that this method was called once, but this method was never called once, then this assert will fail. And suppose if I had this assert here, then this assert would fail and this line won't reach till here. So it is like the how the system.assert works. Like if the assert fails, it won't go to the next line. So it's like that. So data is passed and then I verified all the fields if they are being set correctly. Yes, one more thing I want to bring you to notice, like whenever the transaction starts from here, the contact service, so it will go inside this method. Let's go through the code. It goes here and then it finds some things and then it goes here and then it goes into update count of, okay, update accounts based on count. It goes to this method. Then as you can see, there is a call to another class from here. So it should have gone here, but since we have mocked, this class will never go here. So even if we put a system.debug here, so in this context, in the context of this test method, that system debug will never come. And if it is coming, if the debug is coming from here, if this debug, suppose you have put some debug test, suppose if this debug is coming, that means the mocking hasn't been done properly. So in this context, whenever this is called and from here this is called and this method is called, and suppose if this debug comes during the execution of this test method, that means something wrong has been mocked. The mocking has not been done correctly. So to verify that, what we always do is we put a debug to actually verify that if it is being mocked or not. Then if it is being mocked, why isn't it returning? Then most of the time what happens is the parameters which you have specified and the parameters which it actually is passing, which it is actually passing here, they both are different. So in that case also it won't return any data. So you need to be very confident and verify as well that the parameters you are saying that if it sends this parameter then give this data. So you need to be sure of this part. You need to verify this, that the parameters in the both ends are same. Like suppose here if it was passing abc as id, then even here it should be abc being passed. If it was cde here and it was abc here, then this won't return this list of account. And same I've written for the other one, account selector mock, FW subject selector mock. And again I've created an account record with multiple childs and again I have mocked the selector called here. And then I'm verifying the datas here. Count of contacts is 2 and the account selector called was called once with this parameter and unit commit work was called once. So let's see a sample, like what is the difference actually. You run. So this is the test class with the traditional one. This is a test class with mocking. Okay. So if we see this test class, okay, we'll see first the traditional one. So if we see the limits, we see that socle queries were 2, number of DMLs were 5. So that means 5 DMLs happened and 2 sockles happened in that in the traditional way. But if we see the mocked one, then we can see that number of socle queries were 0, number of DML statements were 0 when the test class executed. So this shows the limits were not even used when we use the enterprise, the ApexMocks to test the class. Another thing is whenever we write test classes for selector, we always need to perform a DML to verify that the database is actually returning the data correctly. In this case, we won't mock the selector calls, but we will actually write unit tests for that. So by creating data for it, so that it verifies that the data being returned from the database is correctly returned. Okay then. Thank you.